This video is going to continue to look at some more examples of solving exponential equations, and we're going to look at using the same properties, the one-to-one, the inverse, and rewriting. This time I'm not going to work this out every single technique. I'm just going to pick one. So if this isn't your favorite technique, you can always use whatever technique that you prefer from the previous video to use to solve these equations. So we have e to the x plus 7 equals 20. Once again here, the first step is to isolate the e to the x. So that means we need to isolate the part that contains your variable. So that means we need to subtract 7 from both sides. So we would have e to the x equals 20 minus 7, which is 13. And now at this point, you can choose whatever technique you prefer to solve for x. I'm simply going to rewrite the exponential equation in logarithmic form. So that means our exponent, which is simply the x, is going to be equal to the natural log. And again, that's because of this is the base is e. So that's like writing log base e. So we have the natural log of 13. And then at this point, all we have to do now is take the natural log of 13. So if you go to the calculator, we can take the natural log of 13 and we get approximately 2.56. So x is approximately 2.56. Okay, for this one I will work out one other way here just to make sure that we understand. If we have e to the x equals 13, you could have thought of this if you wanted to, just taking the natural log, because this is base e, you could take the natural log of both sides. And essentially that's what we did here when we were rewriting the problem. So we took the natural log because natural log and e cancel, and if that's going to cancel, you're going to be left with x equals the natural log of 13. And that's exactly what we had over here. All right, 4 to the x minus 3 equals 25. And here, once again, we want to isolate the term that has the variable, so the 4 to the x, so that we need to add 3 to both sides. So 4 to the x is equal to 25 plus 3, which is 28. And once again, I'm just going to rewrite this one. We know that we can rewrite this as our exponent, which is x, and that's going to be equal to log base 4, okay, because 4 is the base, so it's log base 4 of the 28. And then at this point, in order to solve, we need to use the change of base, which would be the natural log of 28 divided by the natural log of 4. So if we go to the calculator, natural log of 28 over the natural log of 4, we would have ln of 28 divided by the ln of 4. And we get approximately 2.40, or just simply 2.4. Okay. And our next example, we have 8 multiplied by 4 raised to the 6 minus 2x plus 13 equals 41. All right, now with this example, once again, we need to isolate, in other words, we need to get the 4 raised to the 6 minus 2x. We need to get this piece by itself. So that means we need to get rid of the 8 and we need to get rid of the 13. Well, just like any algebraic equation, we're going to get rid of any of the addition subtraction first. So we're going to get rid of the 13. So we would have 8 times 4 raised to the 6 minus 2x. And to get rid of the 13, we would certainly just subtract 13 from both sides. And 41 minus 13, that would be equal to 28. And then we want to get rid of the 8, so we would certainly just divide, because we're multiplying by 8, we would divide by 8 to cancel those out. And we would have 4 raised to the 6 minus 2x equals 28 divided by 8. You could write this as 7/2, or you could write it as a decimal 3.5. And now we need to get rid of the 4. We need to get to the 6 minus 2x. So how can we do that? Well, once again, we could just simply rewrite this from this exponential form into logarithmic form. Well, that means we're going to take the exponent. Well, the exponent is 6 minus 2x. So that means the exponent of 6 minus 2x is going to be equal to the log base 4, because up here our base is 4, so that's the 4 here. So we get log base 4 of 3.5. All right, now we need to get x by itself. So that means we have 6 minus 2x. So the first thing is we want to get rid of the 6. So that means we're going to subtract 6 from both sides of the equation. And we're left with a negative 2x equals log base 4 of 3.5 minus 6. Now, something I'm going to do here, we're subtracting 6. Now, just so that we don't get confused, we're not taking the log of 3.5 minus 6. It's the log of the 3.5. Then we're subtracting 6. So it may be that you want to write this with the negative 6 plus log base 4 of 3.5. Okay, that way it will clear up any confusion that you're subtracting the 6 from the 3.5, whereas we're really taking the 6 away from the entire logarithm. So now we have a negative 2x, and to get rid of the negative 2, we're going to simply divide everything by negative 2. So we would end up with x equals negative 6 plus log base 4 of 3.5 over negative 2. And then we have this log base 4 of 3.5, so we can handle that again by using the change of base. So log base 4 of 3.5, we could think of that as the natural log of 3.5 divided by the natural log of 4, and then all of this is still divided by negative 2. So if we go to the calculator and type this in, we will end up with the answer. So if we go to the calculator, now before we get there, let's look at this problem a little closer here. We need to make sure that we put this entire numerator in parentheses, and we also want to make sure that we have our parentheses here closed around the natural log of 3.5 and the natural log of only the 4. Okay? So if we go to the calculator, we're going to type in parentheses negative 6, and we had plus the natural log of 3.5. Now once again here we have this natural log of 3.5. Make sure we close the parentheses, so we're taking only the natural log of the 3.5 divided by the natural log of 4, and again we're closing the parentheses on this natural log of 4. And then we need to put in another set of parentheses. Okay, now this last set of parentheses I put here, let me scroll back to make sure you see this. That last set of parentheses is going around this entire numerator where I put the parentheses here at the beginning, because we want the entire 6 plus ln of 3.5 divided by the ln of 4. We want this whole numerator now divided by, and let me go back to the original problem. So we want this whole numerator here divided by the negative 2. Now, because we only have one term in the denominator, we can simply just type in the negative 2. We don't have to necessarily put the negative 2 in parentheses. So if we hit enter, we get approximately 2.55 as our answer. All right, moving on to our next example here. We have e to the 2x minus e to the x minus 20 equals 0. And again, this looks similar to a quadratic equation. And if you notice here, we have e to the 2x and we have e to the x. So here we have two pieces that are raised to a power that contain our variable. And like I said, this looks like our quadratic equation, such as ax squared plus bx plus c equals 0. And if you think back, how would we solve this equation? Well, first we would possibly try to factor, or as we did before, we could use the quadratic formula, and that would be x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, I want to point out, notice this is our x. Where does this x come from? Well, the x here is coming from this middle term where we have bx. That's coming from here. So if we look at our problem over here at the left, we have e to the 2x minus e to the x minus 20. Well, that's going to kind of match up with this term here. So instead of x, for us, we're going to have e to the x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So the equation is exactly the same, but now instead of just having it equal to x, it's going to be equal to e to the x. So this is already in order, and we know that here a is going to be equal to the coefficient of the first term here, which is 1. B is going to be equal to here a negative 1, and C is equal to a negative 20. So if we use our formula over here, then we know that we're going to start with e to the x equals, and then we would have a negative b, so that's a negative 1 plus or minus the square root of b squared, so that's negative 1 squared, minus 4 times a, which is 1, times c, which is a negative 20. And this is all divided by 2a, so that's 2 times 1. And keep in mind, this is still, if we bring it down, e to the x. So negative 1 is a positive 1, plus or minus the square root of negative 1 squared here is positive 1. And we have a negative 4 times a negative 20, so that's going to be a positive 80. So you have 80 plus 1 is going to give us 81 over 2 times 1 is 2. And then we're going to end up with 1 plus or minus the square root of 81 is 9. Okay. Now here, that means we're going to have e to the x is equal to 1 plus 9, which is 10, divided by 2 is 5. And we could have e to the x is equal to 1 minus 9, which is going to be a negative 8. And negative 8 divided by 2 is a negative 4. And now at this point, we need to remember 5 and negative 4 is not the answer, because e to the x is equal to 5 and e to the x equals negative 4. We need to solve for the variable x. So once again here, to get rid of this e, we could simply write this in logarithmic form, or we could think of taking the natural log of both sides. So we could think of this as taking the natural log of e to the x equals the natural log of 5, because the natural log of e to the x is going to cancel, so we get x equals the natural log of 5. And if we want to simplify this, we could go to the calculator, and we would take the natural log of 5, and we get an answer of 1.609, so we could round that to 1.61. So x is approximately 1.61. And at this point, maybe you could pause the video and see if you could find out the e to the x equals negative 4. And if we do the same thing, we would get the natural log e to the x equals the natural log of negative 4. And of course, natural log of e is going to cancel, so you're going to get x equals the natural log of negative 4. Now, I'm hoping that if you were careful and you were smart enough here to catch this, at this point you should notice something. We're taking the natural log of a negative 4, And if you think back, is that possible? Well, if you happen to forget, if you go to the calculator and you try to take the natural log of a -4, you're probably thinking you did something wrong or the calculator's wrong. But notice when we take the natural log here, and let me look at my calculator. I'm going to change this down here to make sure I'm in real mode. Second quit. So now if I take the natural log of -4, whoops, get the -4 in there. Notice we get your error is a non-real answer. Okay, now that doesn't mean that we made a mistake here, so I'm going to select number 1 to quit. The natural log of a -4 is undefined. It's not a real number. So if we go back here, this is not going to be an answer for us because the -4 is not in the domain. And if you remember when we talked about the domain and range here of your logarithmic functions, we said that you cannot take the log of 0 or a negative number, because even if we try to take the natural log of 0, we still get an error. Okay, so here you need to be careful. It looks like we're going to have possibly 2 answers, but we really only end up with 1 answer, which is the 1.61 for this equation here.